Welcome back to Springington Math 8. I'm Mr. Burns and I'm going to be your teacher. Today's topic is the last one for our chapter, scientific notation and the operations that go along with it. Let's hop right in. First, I'd really like to do a quick review with you about some things we previously talked about. So scientific notation is a useful tool that allows you to work with very large and very small numbers. It's always put in the form of a times 10 to the xth power. Okay, that a is a number between 1 and 10, and x is the exponent that is either going to be positive or negative depending on the situation that you're in. So the key to evaluating expressions with scientific notation is to group the powers of 10 together and deal with them separately. So let's take a look at this example. The first scientific notation number we have is 3.2 times 10 raised to the 6th power. Now that entire expression is going to be multiplied by 8.7 times 10 to the 11th power. Now I know that seems really confusing, but we're going to break it down in an easy way for you. So first we want to separate the items in the two different equations. First we're going to group 3.2 and 8.7 together, and we're going to put those in their own set of parentheses, and we're going to multiply them in a little bit. Next we're going to take the powers of 10 and their exponents, in this case 10 raised to the 6th power times 10 raised to the 11th power, and that's going to be grouped, and it's also in its own set of parentheses. Now the reason we do this is that it's much easier to deal with these items separately than it is together. So let's look at the next step. So when I multiplied 3.2 times 8.7, I got 27.84. Okay, and now I have times 10 to the 17th power. Now we need to backtrack for a second because you learned the rules of what to do with exponents when the bases are the same in a previous chapter. In this case, I added the exponents together and got the 17th power. Now you may have noticed that this is not entirely in the proper scientific notation format because I actually have a number that's much larger than 10 as the root part of the scientific notation expression. In this case, 27.84 is too large. Remember, it has to be a number between 1 and 10. So how do we get that to between 1 and 10? Well, we can move the decimal place one more time. Okay, and then we're going to add another number to our exponent. So we're now left with 2.784. No longer is it 27.84, but now we've converted it to 2.784 times 10 to the 1st times 10 to the 17th. And again, we need to keep the base of 10 and combine those two exponents. We know that we need to add them together, so we can combine them and get our final answer. So the final answer to this particular scientific notation expression equation is 2.784 times 10 to the 18th. That's it for today, guys. Best of luck solving. See you later.